In this video, we will talk about square numbers, triangular numbers, and Fibonacci sequence. But before we get to that, let's make sure we understand what we mean by natural numbers. These numbers are natural numbers. 1, 2, 3, 4, 5, 6, and it goes on and on. 0 is not included. What are whole numbers? Whole numbers are these numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes on and on. The whole number set is basically the natural number set plus the 0 included. And integers are these numbers: 0, plus minus 1, plus minus 2, plus minus 3, so on and so forth. One more thing. The set of natural numbers is generally written like this, okay? And the set of integers is written like this. I don't have a way of doing it nicely here on my computer, but you get the idea, I hope. All right, let's talk about square numbers. Well, what are square numbers? Well, square numbers are numbers that are like these numbers: 1, 4, 9, 16, 25. Do you see the pattern? The pattern is 1 squared is the first square number, 2 squared is the second square number, 3 squared is the third square number, 4 squared is the fourth square number, 16, 5 squared is 25. So basically, square number is the 100th square number. Let's write it down somewhere. S subscript 100. We use small s. Subscript 100 would simply be 100 squared. And that's it. And these numbers, if you use a dot to represent 1, you can arrange those dots into squares. Okay, there is a visual representation here. How about triangular numbers? Well, they're kind of similar to square numbers. Okay, now when it comes to triangular numbers, if you use a dot to represent 1, then 1 is the first triangular number. 1 plus 2 looks like a triangle, is the second triangular number, which is 3. 1 plus 2 plus 3, which is 6, is the third triangular number, T subscript 3. T subscript 4, or the fourth triangular number, is 1 plus 2 plus 3 plus 4, which turns out to be 10. Now, T subscript N is 1 plus 2 plus 3 plus dot, 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 all the way up to N. So let's see how we can find the 100th triangular number. 100th. Now, by definition, this has to be this. Now, this is nothing but an arithmetic sequence whose first term is 1 and the last term is 100, and there are 100 terms. We can easily find the sum of it by using Gauss's method. Let's do that. We're going to find the sum. Let's call it S. That's what we're looking for. We don't know what it is. And we're going to write it in reverse order as follows. And the sum will still be S. Now, if I add the corresponding terms, I add these two, and so on, and all the way up to these two. What do I get? I get, let's see, I get 101 each time. 101 each time. And this, of course, is 2 times S because I have the sum twice. Now, let's fix that. All right, now this third line, this is my third line, turns out to be 101 times 100 because there are 100 pairs. Therefore, S will be half of that. S is exactly what I'm looking for. Is going to be half of this. So it's going to be 50 times 101. 100 divided by 2 is 50. 50 times 101. And that turns out to be done. That's my answer. So the 100th triangular number is 5050. We use the definition of triangular numbers, definition of arithmetic sequence, sum of the terms of an arithmetic sequence, and we got that the T subscript 100 is just 5050. Okay, let's talk about Fibonacci sequence. Well, Fibonacci sequence is a very interesting sequence, and it has lots of interesting properties. So if you start with, we always start with 1 and 1 when it comes to Fibonacci sequence. It's a unique sequence. And the third term is the sum of the 2 previous terms. So any term beyond the second term is the sum of the 2 previous terms. So 13 is 8 plus 5. Take a look. So 13 is 8 plus 5, 8 is 5 plus 3, 5 is 3 plus 2, 3 is 2 plus 1, 2 is 1 plus 1. We always start with 1 and 1. And then to find the third term, we add the 2 previous terms. To find the fourth term, we add the 2 previous terms. So it's an interesting sequence you should be familiar with.